So for today, we will have exponential function and logarithmic function. Different properties of the graph of logarithmic function. We will also have some basic steps on how to graph exponential function. So the most essential learning competencies of this lesson are the following. First, represents exponential function or logarithmic function as table of values, equation, and graph. Next, determine or find the domain and range of an exponential function or logarithmic function. And then last, determine the intercepts and asymptotes of an exponential function and logarithmic function. So we recall the definition of an exponential function. So it is defined as f of x equals a raised to x, where a is greater than 0 and a should not be equal to 1, as well as x and x is any real number. So again, it's different from any other function that we have because the variable is in the exponent. So recall in the activity that we have. So we have the graph of the basic exponential function f of x equals 2 raised to x. So let's now compare the graphs of 2 raised to x, 3 raised to x, and 4 raised to x, so that we can identify the different properties about the graph of an exponential function f of x equals a raised to x, where a is greater than 1. So let's start with the domain. What is the domain of an exponential function? So domain possible values of x. So as you can see in our graph, so we have here the values of x. So that means the domain is the set of all real numbers. How about the range? What is the range? Is there any possibility that our range will be a negative number? So range is just positive real numbers, where x should be greater than 0. Or rather, y should be greater than 0. X-intercept. So we have an x-intercept while your graph intersects the x-axis. So we don't have any x-intercept because there is no x value that you can put in the function to make it 0. On the other hand, how about the y-intercept? Take a look at the graph. So we have this point. So this point is 0, 1. So the y-intercept is always 0, 1 because a raised to 0 is equal to 1. Again, this is for the function in the form of f of x equals a raised to x. Are this exponential function increasing or decreasing? So the graph is always increasing. Can you see the horizontal asymptote for this function? So the horizontal asymptote is our y equals 0 as x approaches negative infinity. So let's recall the reflection of 2 raised to x, which is 2 raised to negative x, which is the same as y equals 1/2 raised to x. So in this case, we have the graph of 2 raised to x and 1/2 raised to x. So basically, they have the same properties, but if your base is between 0 and 1, like 1/2, it will be decreasing. If it is greater than 1, it's increasing. So it will have the same domain, range, and intercepts and asymptotes. The only difference is, again, it's decreasing. So again, the different properties about the graph of an exponential function are the following. First, the domain is all real numbers. Second, range is positive real numbers. Third, there's no x-intercept. Fourth, the y-intercept is always 0, 1 because f of 0 is equal to 1. And the fifth, the graph is always increasing for a is greater than 1 and it's decreasing if it is between 0 and 1. Y equals 0 is our horizontal asymptote and the function is 1 to 1. So the basic procedure for graphing the exponential function is first, you look for the y-intercept. So it's a y-intercept, meaning we'll let x be equal to 0 or we'll look for f of 0. And then label that point. To get other points, all you have to do is to find f of negative 1 and f of 1. Then connect the 3 points with a smooth curve with the x-axis as our horizontal asymptote. So let's just have this drill. So without graphing, tell whether each function is decreasing or decreasing. So again, how do we know if we have an increasing, so growth, and decreasing, decay, exponential function? So we are to check our base. So if the base is greater than 1, it's increasing. And if it is between 0 and 1, it's decreasing. So here it's increasing. The base is 3 over 2, which is 1.5. Here also increasing. The base is 2, 0.9 raised to x decreasing, and 3 over 11x decreasing. So increasing is associated with growth. Decreasing is associated with decay. As you recall, the different application of exponential function, such as exponential growth and exponential decay. So what if you have f of x equals 3 raised to x? What will happen if we have f of x equals 3 raised to negative x, or 1/3, and negative 3 raised to x? So the following will give the reflection of the graph. So this is a kind of transformation that makes the new figure a mirror image of the original figure. As we recall the activity in our Desmos activity, so if it is reflected over the x-axis, if we have the function of negative x, and if it is reflected rather in the y-axis if it is negative of f of x, or the negative of the function. So here, 3 raised to x, its reflection over the x-axis is f of x equals 1 over 3 raised to x, which is the same as 3 raised to negative x. And the other one is its reflection over the y-axis, negative 3 raised to x. So I have 3 sets of function here. This is already presented also in our Desmos activity. So let's just recall for exponential function. So we have what we call translation. So this is the movement of the graph, shift or movement of the graph in its location without changing the shape of the graph. So we have the exponential function in the form of y equals a times b raised to x plus c plus d. So this is the first set. So the red one is the graph of f of x equals 2 raised to x. Observe what happened to the point if you have the function 2 raised to x minus 1, which is the blue graph, and then 2 raised to x plus 1, which is the green graph. So from our basic function, you see the horizontal translation of the graph. So minus 1, meaning it is shifted 1 unit to the right. So the points are shifted 1 unit to the right. And if it is plus 1, it is shifted 1 units to the left. So this is the movement to the right or to the left. It is minus 1 to the left, plus 1 right. On the other hand, if we added or subtracted to the function, that is the vertical translation. So again, you have the basic points of the function in red graph. And then the black one, so this time it is minus 1 on the function, movement is downward. And if it is plus 1, the movement is upward. So this is the vertical translation of the graph. So it's possible that we have the same horizontal and vertical translation. So here, this is 3 units to the left and 1 unit downward. Here, 4 units to the right and 3 units upward. So that's the translation of the graph. So as we summarize the translation of the graph, we have the following. So the value of A, aside from it gives you the reflection of the graph, is the vertical stretch of the graph. How narrow or wider is your graph? How about B? This is the curve of the graph. So this determines if you have an increasing or decreasing graph. So if B is greater than 1, it's increasing. If it is between 0 and 1, it's decreasing. C is the horizontal translation, again right or left, and D is the vertical translation, up or down. So this time, recall what's the inverse of the exponential function. So this is the same as y equals 2 raised to x, since f of x is equal to y, and x equals 2 raised to y by interchanging x and y, and this is equal to x equals 2 raised to y. Solving y, this is the same as log y is equal to log of a log of x to the base 2 or with the base 2, which is the basic logarithmic function. So logarithmic function, as we have in the activity, is just the inverse of exponential function. So as you can see, if you have logarithmic function to the base a, where a is greater than 0 and a is not equal to 1, it's just the same as y equals to a raised to x. So this is the logarithmic form and this is the exponential form. So if I'll ask you to convert 16 equals 4 squared, this is just equal to log of 16 with the base 4 equals to 2. And on the other hand, if we have log of 1/8 to the base 2 equals negative 3, it's just equal to 2 raised to negative 3 equals 1 over 8. So observe, as you can see, when we convert an exponential to logarithmic form, notice that the exponent and the exponential becomes what the log is equal to. So, given the graph of an exponential function and a logarithmic function, if we'll combine them, since they are inverse of each other, they are reflected about the line y equals x. To be specific, here, the base being used is b. So b is greater than 1. So you have the basic function f of x equals 2 raised to x. And its logarithmic function is log of x to the base 2. And if it is between 0 and 1, so we have f of x equals 1/2 raised to x. And f of x equals log of x to the base 1/2. So as you can see, they are just inverse of each other. So we have already the characteristics of the graph of an exponential function a while ago. So let's compare it to the characteristics about the graph of a logarithmic function in the form of f of x equals b raised to x, logarithmic function log of x to the base b. So since they are inverse of each other, we have domain is all real numbers for exponential. On the other hand, it's range. Range is positive real numbers for exponential, domain for logarithmic. If we have no x-intercept, then for exponential, we have no y-intercept for logarithmic. If we have y-intercept as 0, 1, we have the x-intercept as 1, 0. Recall, the x and y interchange, they trade places. If we have an horizontal asymptote for exponential function, we have a vertical asymptote, which is the y-axis. And both functions are 1-to-1. So, getting the summary of this one, again, this is what you explore in the activity in the Desmos. A is the same, the stretch or the shrink of the graph. B is the curve of the graph, or if it is increasing or decreasing. C, horizontal translation, right or left. And then D, vertical translation, up or down. So let's try. Identify the domain, range, intercept, asymptote of the given function. So we have So let's have for the exponential function f of x equals 3 raised to x plus 1. So what will be the domain? So the domain is just x, such that x is an element of all real numbers. And the range, so the range will be y such that y is greater than negative 2. Take a look. So this is, the graph is moved 2 units downward. So you have also as your horizontal asymptote, y equals negative 2. Again, here it's horizontal asymptote. And our intercept, so intercept, this is y-intercept, because we don't have any x-intercept. So y-intercept, again, we simply let x be equal to 0. So 3 raised to 0 plus 1 is 3 raised to 1. So that is 3 minus 2. So the y-intercept is 1, 1, 0. So that's for exponential function. So as you can see, this one, you can clearly have this one if you know if you can see the graph. So remember in the explore activity, in the Desmos activity, in which you are to move the slider, so that explains the different properties of the function. So as you can see, this becomes the horizontal asymptote. So here, recall this one cannot be negative, right? So the domain is x such that x is greater than 4. So in set builder notation. How about our range? So again, it interchange, so y such that y is an element of our real numbers. So here we have x-intercept. So we let y be 0. So this one is the same as, if y is 0, so this is 3 raised to 0 equals x minus 4. So recall, anything raised to 0 is 1. So we have x equals 5. So the x-intercept is 5, 0. So here our asymptote is vertical asymptote. So that is associated with this one. So x is equal to 4. So as you can see here, the value that being added or subtracted. So if it is minus, it's positive 4. If it is plus, it's negative 4. As you can recall in the properties or in the general form of the logarithmic function. So again, we have the sample and finding the domain and range, the intercepts and asymptote for an exponential function and a logarithmic function. So again, we recall the different properties of exponential function and logarithmic function. So since they are inverse of each other, the domain and range interchange. Domain is all the real numbers. On the other hand, for logarithmic, it's the range that is all real numbers. The range is positive real numbers for exponential. For logarithmic, it's the domain. No x-intercept for exponential, no y-intercept for logarithmic. Y-intercept is 0, 1. X-intercept is 1, 0. Again, this is in the form of the function f of x equals log of x to the base b, b is greater than 1, and f of x equals b raised to x, b is greater than 1. So you have 0, 1 and 1, 0 respectively. Asymptote, horizontal asymptote for exponential function, and vertical asymptote for logarithmic function. And the two functions are one-to-one because they are inverse of each other.